Consensus estimation and truthfulness with high probability. We now look at an alternative reduction to the decision problem and approach to competitive auctions that does not use random sampling. This approach leads to a truthful digital goods auction that is 3.39 competitive with F2. However, rather than presenting that result, we present a more general version of the approach with wider applicability. To achieve the greater level of generality, we will need to relax our solution concept and talk about truthfulness with high probability. Definition 13.43. A randomized mechanism is truthful with high probability. Say 1 minus epsilon if and only if for all I, vi, bi, and b minus I, the probability that agent I benefits by bidding non-truthfully is at most epsilon, where the probability is taken over the coin flips of the mechanism. In other words, for all I, vi, bi, and b minus I, the probability of ui of vi, b minus I, which is greater than or equals to ui of bi, b minus I, is greater than or equals to 1 minus epsilon. The techniques presented in this section, when applied to the digital goods auction, result in a mechanism that is truthful with probability 1 minus big O of 1 over m, where m is the number of winners in F2. Thus, as the input instance grows and there are more winners, the probability that non-truthful reporting by the agents is beneficial approaches as 0. Let us first describe the general idea. Consider attempting to design an auction to compete with profit benchmark G. Suppose that there exists a profit extractor for G, profit extract GR, which obtains profit R from B if R is less than or equals to G of B. Then the mechanism we would like to run is the following. 1. Compute R equals to G of B. 2. Run profit extract GR on B. This fails, of course, because generally the R computed in step 1 is a function of an agent's bid, and therefore the agent could misreport their bid to obtain an R value that results in a more favorable outcome for them in step 2. On the other hand, it is often the case that a single agent only contributes a small fraction to the profit G of B. In particular, suppose that there is some rho such that for all I, G of B minus I is in the closed interval between G of B over rho or G of B. In this case, G of B minus I is a pretty good estimate of G of B. The idea then is to replace step 1 above with 1 prime. Compute R equals to little r of G of B, where the probabilistic function little r dot is a rho consensus beta estimate. Definition 13.44. A randomized function little r dot is a rho consensus if for all v greater than 0 with a high probability all v prime within the closed interval between v over rho or v satisfy v r of v prime equals to r of v. Intuitively, if little r dot is a rho consensus, then with high probability little r of g of b is equals to little r of g of b minus I for OI. This will imply that bidder I has very small probability of being able to influence the value of little r of g of b, and thus we will be able to guarantee truthfulness with high probability. Definition 13.45. A randomized function little r dot is a beta estimate if for all v greater than 0 it satisfies little r of v, which is less than or equals to v, and the expected value of r of v is greater than or equals to v over beta. Intuitively, if little r dot is a beta estimate, then little r of g of b is close to but less than g of b. If this is the case, then running profit extract gr on b with r equals to r of g of b will extract a revenue r which is close to g of b. Of course, even in step 1 prime, r is a function of all the bids, so the resulting auction is not truthful. However, under some mild assumptions, it is possible to show that in the case that little r of g of b is a consensus, no bidder has an incentive to deviate and misreport their valuation. The resulting mechanism is truthful with high probability. We now show how to construct the function little r dot. Definition 13.46 R alpha. Given alpha greater than 1, the randomized function R alpha that picks U uniformly from the closed interval between 0 and 1 and is little r alpha of v equals to v rounded down to the nearest little alpha to the I plus u for integer I. Straightforward probabilistic analysis can be used to prove the following lemmas. Lemma 13.47. Little r alpha is a row consensus with probability 1 minus log with base alpha to the row. Lemma 13.48. Little r alpha is a beta estimate with the beta equals to alpha times log alpha over r minus 1, alpha minus 1. In the most general setting of single parameter agents, given the existence of a profit extractor for a benchmark G, these lemmas can be combined with the consensus estimate profit extraction auction CPE described above to give the following theorem. See exercise 13.11. Theorem 13.49. Given a monotone profit benchmark G for a single parameter agent problem specified by cost function C dot and a monotone profit extractor profit extract GR, CP is a alpha times log alpha over alpha minus 1 competitive and truthful with probability 1 minus log base of alpha to the row on input B satisfying G of B minus I, which is in the closed interval between G of B over row or G of